Let's just look at this issue of rounding off numbers, right? If you should write a number, for example, you're writing down pi. Let me just take my calculator and look at this number pi and see what the value of it was. Again, I remember, but I just want to take back a look at it. Advanced mode. No, pi equals 3.141592654. Let's write that down. Let me type that down. Pi is 3.141592654. Alright. If you are going to write pi and you're going to stop at this point, you would say 3.1. Good. If you're going to stop at 4, you would say 3.14. Nice. If you're going to stop at 1, you would say 3.141. No, it would be 2, because there's this rule that says if you're going to stop at a certain number, for example 1, you must look to the right and see the next digit. If that digit to its right is 5 or more, you should go back to where the digit you're going to stop and add 1 to it. In this case, it turns to 2. They're saying that if you're going to stop here and you look to the right and the digit that is to the right is less than 5, then you just keep the digit where you're going to stop and write it down. And the same thing applied to this one. Alright, so that is a rule of rounding off. Later on we'll look at writing down numbers to a certain number of decimal places and to a certain number of significant figures, right? But for now we'll just look at general rounding off. No. What happened a while ago? What happened to my screen? Okay, good. My finger accidentally touched something. Alright. No. Why did they come up with this rule? Is it valid and does it really work in practice? Let's examine an example. Let's say you measure a certain distance. You measure the distance from here to here, and you get 1,987 meters. So you measure from here to here. But then you're saying write it to the nearest whole number, or put the values in kilometers. It's the same as writing 1,000 odd meters to the nearest whole number, because you know that 1,000 meters is equal to 1 kilometer. 1 kilometer. How do you write this in kilometer? To the nearest kilometer. If you write 1.987 kilometers, they would say, whoever is asking you to do it, it could be a customer, a supervisor, or somebody else, they want you to write to the nearest kilometer, right? Not 1.98 something. Now what would you write? Would you write 1 kilometer, or would you write 2 kilometers? The rule that we're talking about really tells you to write 2 kilometers, because you're stopping at the 1 and the number to its right is more than 5. If it's 5 or more, you go back and add 1 to this. So you would write 2 here instead of 1. Now let's see something. If you would write 1 kilometer, the 1 kilometer would be a bit short, and you would lose some value. You would lose, if you subtract 1000 from this and you write 1 kilometer, you would have lost all of this distance, the 987. So you would lose 987 meters, right? If you write 2 kilometers, you would overstep the distance a bit, so you would gain a certain distance. How much would you gain? It would be 2000 meters minus 1987 meters. So it's 87 and 13 meters. Now which one of these, well, GAIN, which one of these would be closer to the original value that you measured? Of course, it's the 2 kilometers that would be closer. So this 2 kilometer is more accurate than the 1 kilometer, right? 13 meters is a much shorter distance than 987 meters. So by writing 2 kilometers, you're much closer to the original measurement than if you wrote 1 kilometer. You would be much far away by writing 1 kilometer. So it's for accuracy, right? When you round off a number, you lose or gain a certain value. But when you obey that rule, the new number you have is closer to the old number that you originally had. All right, so it's more accurate when you obey that rule. Now, of course, suppose you're tiling a floor and you count, you measure and calculate the number of tiles. In that case, it would be the area, the floor area over the tile area, and you get, for example, 153.1 tiles. It could be that the tile area is in square feet or square meters. The floor area maybe in square feet or square meters. But if you get the floor area is in square feet and the tile area in square feet, and you divide them, and you find out that you're going to get 153.1 tiles, right? In reality, you would order more because some of them might break accidentally or you have to cut them. But in this case, if you try to work so carefully and try to spend as little money as possible so that you order only the number of tiles that you need at first, right? you order only the number of tiles that you need now, because you're on a low budget. You won't get any more money until a few days later to continue tiling. The minimum number, how many tiles would you order? If you're rounding off this number to the nearest whole number, generally you would say 153, right? Because the number to the right of 3 is 1, is only 1, so you'd round down. But the thing is, you would have a little space left, so you need a bit more, and the hardware does not sell 0.1 tiles, so you would have to buy 154 tiles and then cut the extra, cut one of them into 1/10 to fill in that little space that you're going to need to fill in. All right, so in certain situations like that, you would keep that number upwards. You would put that number upwards to 154, whether it was 153.9 or 153.1 or 153.2. You would put the number upwards to the next higher one. But generally, when you talk about rounding off, most of the situations that you meet upon is like this, where you can play around with the number as you want. You're not forced to round up like in the tile situation, right? But basically, you do this, you obey that rule for accuracy. So the rule of rounding off, that rule is to ensure accuracy. All right, so later on we'll look at rounding off to a certain number of decimal places, and then later on after that, rounding off to writing a number really to a certain number of significant figures. All right, so I'll see you then.